So we have already looked at the present value of an ordinary annuity. Now let's look at the present value of annuities due. So let's recall what is an annuities due. So annuities due is a series of fixed receipts or payments starting at the beginning of each period for a specified number of periods. So basically the difference between annuities due and ordinary annuity is that annuities due is where the receipt or payment is done at the beginning of each period, whereas in ordinary annuity it is done at the end of each period. So in the lottery example, let's say the first option now is that a payment of 1,000 rupees will be made at the beginning of each year for the next 3 years. And the second option is a lump sum payment today. So option number 1 will look something like this on the time scale. So this is 0, 1, 2, 3. And the payments are being made at the beginning of each period. So 1,000 rupees, 1,000 rupees, 1,000 rupees. So this is at the beginning of the first year, this is at the beginning of the second year, and this is at the beginning of the third year. Now I've kept this as positive because this is a receipt of payment, so this is coming into your pocket. Now you are trying to find out the lump sum amount that you will get as part of option 2. So if instead of taking these 3 payments, you take one payment, let's say X rupees, right up front, how much should this amount be? Now you inquire in the banks and they can offer 5% interest per year compounded annually if you deposited this lump sum amount in the bank. So this X rupees is nothing but the present value of this annuity. So in other words, the present value of an annuity is the single lump sum payment today that would be equivalent to the annuity payments spread over the annuity period, or it is the amount today that would permit withdrawals of an equal amount at the beginning, in case of an annuity due, of each period for n periods. So basically, if we deposit an amount of X rupees in the bank today at 5% interest per annum, we should be able to withdraw 1,000 rupees at the beginning of the first year, 1,000 rupees at the beginning of the second year, and 1,000 rupees at the beginning of the third year. So here, because we have to find the present value, we'll use the concept of discounting, which is nothing but the opposite of compounding. So if we break down this X rupees into 3 parts, so we say PV1 is the amount which we'll get today, and today it is equivalent to 1,000 rupees. PV2 is the amount that if we put in the bank today at 5% interest per annum for 1 year, we'll be able to withdraw 1,000 rupees at the end of first year or at the beginning of the second year. And PV3 is the amount of money today that if we keep in the bank at 5% interest per annum, we will be able to withdraw 1000 rupees at the beginning of the third year. So these three values, PV1, PV2, PV3, will total up to this X rupees. Here we'll say the total present value, or X is equal to the present value. So we now have to find this present value. Now first let's find out the values of PV1, PV2 and PV3. Now let's consider this case of PV3. So here we want to find out the amount of money which, if invested today at 5% interest compounded annually, will give us 1000 rupees at the beginning of the third year. And in compound interest terms, basically it's a period of 2 years. So the formula for compound interest is the final amount is equal to the initial principal into 1 plus r by 100. Now r by 100 we'll consider as I, to the power n, where n is the number of compounding periods. So we want to find the present value, that is the original sum of money. So P is equal to A divided by 1 plus I to the power n. Now here A in each of these cases is 1000 rupees, because 1000 rupees is what we are getting for PV1 at the end of the tenure, PV2 and PV3. So in case of PV3, this amount will be equivalent to the final amount that we are getting, that is A divided by 1 plus I to the power 2, because this is being compounded for 2 years, 1 and 2. So A is 1000, this is this 1000 here, divided by 1 plus I is 5 divided by 100. So 5 divided by 100 will be 0.05 to the power 2. So this is 1000 divided by 1.05 square. So this is equal to 907 rupees. Now similarly, let's find PV2. So this is again A divided by 1 plus I to the power 1, because this is being compounded for 1 year. So this is 1000 divided by 1 plus 0.05 to the power 1, which is 1000 divided by 1.05. So this is 952.4 rupees. And PV1, this will be equal to A divided by 1 plus I to the power 0. 0 because this is not even being compounded. This is the amount of money which we are getting at the beginning of the entire tenure. So this is not attracting any interest. So the present value is the same. So this is equal to 1000 divided by 1 plus 0.05 to the power 0, which is 1000 divided by, now anything to the power 0 is 1, so this is 1000 rupees. So PV1 is 1000, PV2 is 952.4 and PV3 is 907. So the total is 2859.4 rupees. So this is the value of this X rupees, which if invested today at 5% interest compounded annually will allow us to withdraw 1000 rupees at the beginning of the first year, 1000 rupees at the beginning of the second year, and 1000 rupees at the beginning of the third year. So here basically what we have done is we have found the present value by adding up PV1, PV2, PV3, and PV1 is nothing but a divided by 1 plus I to the power 0. Now this present value is for 3 years, so it was a divided by 1 plus I to the power 0 plus a divided by 1 plus I to the power 1, a divided by 1 plus I to the power 1 plus a divided by 1 plus I to the power 2. So now let's try to find out a generic formula for finding out the present value of an annuity due. So let's convert this 3 to n. So then we get PVN is equal to, now let's first put this term here. So a divided by 1 plus I to the power n minus 1. Because in case of a 3-year annuity, because this is an annuity due, the compounding periods were 2. So this is n minus 1 plus a divided by 1 plus I to the power n minus 2. So this is for n minus 2, and this will continue depending on the value of n, and at the end we'll get a divided by 1 plus I to the power n minus n, which is 0, and anything to the power 0 is 1. So here we'll put this as a. Let's say this is our equation number 1. Now let's multiply the left hand side and the right hand side by 1 divided by 1 plus I. So multiply both sides by 1 divided by 1 plus I. So now we'll get, or 1 divided by 1 plus I into PVN is equal to 1 divided by 1 plus I into bracket this whole expression. So a divided by 1 plus I to the power n minus 1 plus a divided by 1 plus I to the power n minus 2, so on, plus a. So or this is PVN divided by 1 plus I is equal to, now let's open the bracket. So first term will become a divided by 1 plus I to the power n minus 1 into 1 plus I. Now let's consider this as to the power 1 is the same. So 1 plus I, or 1 plus I to the power 1, plus, now we'll multiply this with the second term. So a divided by 1 plus I to the power n minus 2 into 1 plus I to the power 1, and the last will become a divided by 1 plus I. So or PVN divided by 1 plus I is equal to, now the denominator here is 1 plus I to the power n minus 1 into 1 plus I to the power 1. So we know that x to the power n minus 1 into x to the power 1 can become x to the power n minus 1 plus 1. Minus 1 plus 1 gets cancelled, which is equal to x to the power n. So here 1 plus I can be considered as x. So a divided by 1 plus I to the power n minus 1 plus 1, which is nothing but n, plus a divided by, now this will become n minus 2 plus 1. So minus 2 plus 1 is minus 1. So 1 plus I to the power n minus 1. And the last will be 1 plus I. Now let's consider this as equation number 2. Now let's subtract 2 from 1. So actually we don't need this bracket here, so let me remove it. So since we are subtracting 2 from 1, we'll put a negative sign on every term of equation 2. So minus, 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 minus. So our left hand side becomes PVN minus PVN divided by 1 plus I. So PVN minus PVN divided by 1 plus I is equal to, now on the right hand side we have A divided by 1 plus I to the power n, which is not there in equation 1. Then in equation 2 we have A divided by 1 plus I to the power n minus 1, which is there in equation 1. So this and this gets cancelled. Similarly, the remaining terms in equation number 2 will get cancelled with the terms in equation number 1, and we'll be left with this A in equation number 1. So we have A minus A divided by 1 plus I to the power n. So A minus A divided by 1 plus I to the power n. Or let's say we take PVN as common, so 1 minus 1 divided by 1 plus I is equal to, here we'll take A as common, 1 minus 1 divided by 1 plus I to the power n, or PVN is equal to A into 1 minus 1 divided by 1 plus I to the power n divided by 1 minus 1 divided by 1 plus I. So basically we have taken this term to the right hand side. Now let's try to further simplify this equation. So now let's take the LCM for the numerator as well as the denominator. So the numerator, the LCM is 1 plus I to the power n. So the first one will become 1 plus I to the power n minus 1 divided by, for the denominator the LCM is 1 plus I, and the numerator will become 1 plus I minus 1. So this is equal to A into bracket 1 plus I to the power n minus 1 divided by 1 plus I to the power n. Now in the denominator this 1 gets cancelled with minus 1, so the denominator becomes I divided by 1 plus I. So this is equal to A into 1 plus I to the power n minus 1 divided by 1 plus I to the power n. Now let's take this denominator into numerator, so this will reverse, into 1 plus I divided by I. So here we have 1 plus I divided by 1 plus I to the power n. So x divided by x to the power n. Now this can also be written as x divided by x to the power n minus 1 plus 1, and this can also be written as x divided by x to the power n multiplied by x to the power minus 1 multiplied by x to the power 1. Now this is also x to the power 1, so this gets cancelled with this, so this is 1 divided by x to the power now n minus 1. So here this will become 1 plus I to the power n minus 1. A into 1 plus I to the power n minus 1 divided by 1 plus I to the power n minus 1. So basically this got cancelled with this, and this became 1 plus I to the power n minus 1 into I. So into I. Now we can further simplify this by A into 1 plus I to the power n divided by I into 1 plus I to the power n minus 1 minus 1 divided by I into 1 plus I to the power n minus 1. So again here the numerator can be written as n plus 1 minus 1. So 1 plus I to the power n minus 1, and this gets cancelled, and this will become 1 plus I to the power 1. So this becomes A into 1 plus I divided by I minus 1 divided by I into 1 plus I to the power n minus 1. Now let's take this one even further. So this is the equation we got in the previous step. Now here let's take this portion here, which is 1 divided by I into 1 plus I to the power n minus 1. Now this can also be written as 1 divided by I into 1 plus I to the power n into 1 plus I to the power minus 1. Now the numerator can be written as 1 plus I to the power 0, because anything to the power 0 is 1, divided by I into 1 plus I to the power n into 1 plus I to the power minus 1. Now 0 can be written as 1 minus 1. So 1 plus I to the power 1 minus 1. 1 minus 1 is 0. Divided by I into 1 plus I to the power n into 1 plus I to the power minus 1. Now the numerator can also be written as 1 plus I to the power 1 into 1 plus I to the power minus 1. And denominator is I into 1 plus I to the power n into 1 plus I to the power minus 1. Now these two get cancelled. So this is equal to 1 plus I divided by I into 1 plus I to the power n. So now this, if we put in this equation, our equation becomes A into, this first part remains as it is, so 1 plus I divided by I minus 1 plus I divided by I into 1 plus I to the power n. Now here we can take 1 plus I as common, so this becomes A into 1 plus I 1 divided by I minus 1 divided by I into 1 plus I to the power n. So this is the formula for finding present value in case of an annuity is due. Now if you recollect, the present value in case of an ordinary annuity is A into bracket 1 divided by I minus 1 divided by I into 1 plus I to the power n. So in case of annuity due, we have added a 1 plus I. So we can also say present value of annuity due is equal to present value of ordinary annuity into 1 plus I. Now let's take this formula and use this in our example. So in our example, we were trying to find out the present value of an annuity which is a 3-year annuity. So 0, 1, 2, 3, where 1000 rupees is being paid at the beginning of each year, and the interest rate is 5%. So the present value will be equal to A, which is the annuity amount, which is 1000, into 1 plus I. I is the rate of interest divided by 100, so 5 divided by 100, which is 0.05, into bracket 1 divided by I, which is 0.05, minus 1 divided by I, which is 0.05, into 1 plus 0.05 to the power n, which is 3, because this is a 3-year annuity. This is 1000 into 1.05. Now let me pull my calculator and calculate this portion. So let's first take this part. So this is 1.05 to the power 3. So 1.05 cube into 0.05 and reciprocal of this. And now this is negative. To this we have to add 1 divided by 1.05. So 0.05 reciprocal. So this is equal to 2.723 multiplied by, so let me first note this down. So this is 2.723. Now we have to multiply this by 1.05 and 1000. So 1.05 into 1000. So this is equal to 2859.4 rupees. Now this is exactly the same answer that we had gotten by calculating PV1, PV2, PV3 and adding that up to find the present value.